look at the future and present value of a compound interest account. Okay, so for compound interest, this formula we have here, which is A, which is the future value or the future amount, is equal to the principal or the present value, what you have right now, multiplied by 1 plus I to the power of n. A little different than that simple interest formula I showed you, but there's some additional calculations we have to make. The I, for instance, usually stands for interest, but it's actually compound interest, which means we have to calculate the compounded interest. I is actually the interest rate divided by the compound period, and we'll talk about what those two are. And n is the number of terms, and the number of terms is the compound period, usually times the number of years. Okay, so let's look at the first question. Oh, what the? Okay, do that. Oh, that worked out. Okay, Eric has $500 he wants to invest for 42 months. In an account that earns 3% per year. I missed that. Compounded monthly. Okay, so again, important stuff. 500, 42 months, 3% compounded monthly is what's important in this question. Okay, I know that earns isn't spelled right. So let's talk about what is what. 1 plus I to the power of n. Well, I is equal to R over C. So the interest rate is that 3% or 0.03 as a decimal. The compound period is something new. Compound period is monthly. So monthly means how many times does it occur, and because we said it was per year, that's the time frame. How many months occur in the course of a year? 12. So your C value, okay, is equal to 12. And your R value is 0.03. So your I is actually calculated by dividing those two. Okay, so it actually seems like a much smaller amount of interest, but it isn't. You earn a little bit more. 0.3 divide 12, 0.025. Okay. Okay, so there's our I value. And the N value. N is the compound period times the number of years. Our compound period is still the same. Compound period is still 12. Our years are a little different. We're in months in this one, right? So we have to convert this to years. 42 months, what did we say it was? 3.5?
Yeah, 3.5.
Yeah. So 3.5. So your N value, 3.5 times 12. That's right. I didn't even need to say that. I'll tell you why that happened. 42, which is the exact months, and that's how many compound periods are occurring. Because they said it was a monthly compounding thing, we could have actually just strictly taken this. Normally what would happen is you would say something like 3.5 years, and because it happens monthly, you multiply 3.5 times those 12 months, and you get your 42 months. They already kind of told us that, which is nice. So N is 42. So now that we have these values, and our present value, what we have right now is our 500. We can go about calculating. A is equal to the 500, 1 plus I, which is 0.0025, all to the power of 42. Okay, we'll calculate inside first, which is 1.0025. We put it to the power of 42, and then that's a 2, not a 5. We multiply by 500. So we could probably do the last step all in our calculator in one step here. 1.0025 to the power of 42 equals, and that value times 500 is how much it is? 555.28. 555.28. And if you remember from our old simple interest question we did, the person actually only earned 552, so $3 more ish, not a huge amount. But as time passes, this starts to really accumulate, and you get much, much more money compared to a simple interest account. Mm-hmm. Okay. Now they'll sometimes show you two different formulas for future and present, but I forgot that happens. Get rid of that after. This is a present value question. I'm going to show you how you can use the exact same formula to do it. Okay. So same concept. Eric wants to have $1,000 in 91 months, so that's important. His account still earns that 3% per year This time it's compounded semi-annually, so not as quickly. The faster something compounds, the more money you will earn on it. Okay? How much should he invest today? Okay, so we're looking at our A equals P, 1 plus I to the N. We know I is the interest rate, 0.03, divided by semi-annually. Semi-annually is only twice a year. Okay? So we're going to go twice a year here. So when you divide that in half, your I value is equal to 0.015. Okay? And our N is the compound periods, so it's 2, times the number of years. 91 months as a number of years is like a decimal, I believe.
Yeah, it's like 7 point something. 7.6.
Yeah, 7.6. So we're going to leave it as a fraction, multiply it as a fraction. So 2 times 91 over 12. Okay, which means our N is going to be equal to, it's actually equal to whatever 91 over 6 is. Okay, that would be kind of like a reduced value. I don't think it's going to give us a non-repeating. Let's see. Nah, still repeating. So we'll leave it as a fraction. So there's our N value. We'll have a fractional N value. You guys did exponents with fractions. Okay, good. And our start value is 1,000. This is what we start. Oh no, I lied. That's not what we start with. They want to have $1,000 in the future, right? So the present value is what we're trying to find. So we plug in 1,000 for our A is equal to P is unknown. 1 plus our I value this time is 0.015. And our N is a fraction of 91 over 6. Okay. Same concepts, we just have to isolate for P. So we'll calculate what's on the right here, and we'll put it to some decimal amount. This is going to be 1.015, so 1.015 to the power of a fraction 91 over 6. Okay, so we got a value now, 1.253-ish, 253, very close to that. And then to isolate for P, we do 1,000, divide that amount, 1.253. And our present value is 1,000 divided by, and I'm going to use that exact value. I'm able to just pull it down here. So 79787. 79787. So in order to have $1,000 91 months from now, let me scroll up just enough. Yeah, almost. You need $797.87 into that account right now. In the simple interest account, you need $815. So you need less money because it's accumulating money faster. So these accounts are more efficient, or they earn more money than a simple interest account will. Okay.